Imagine a boulder perched at the edge of a cliff, motionless, yet brimming with potential. While it appears stationary, it's holding something extraordinary: energy, just waiting for a nudge. This energy, known as potential energy, is the power stored in an object due to its position or configuration, and today we'll uncover what makes it so fascinating. At its core, potential energy is like a savings account for energy, stored away until the moment comes to spend it. Objects have potential energy because of their position in a force field, like Earth's gravitational pull, or due to their arrangement in relation to other objects. It's the energy of what could happen, a state of readiness to transform into movement, heat, or other forms of energy. Let's start with gravitational potential energy, the most familiar type. This comes from an object's height relative to a lower point. For instance, when you lift a book off the floor, you're actively giving it potential energy. The higher you lift it, the more energy it stores, determined by the equation pH, where m is mass, g is gravitational acceleration, and h is height. If someone accidentally drops that book, the potential energy converts into kinetic energy, sending it plunging downward. But gravitational potential energy isn't just about everyday objects. It's also the principle behind massive systems like hydroelectric dams. The water stored high in a reservoir has a tremendous amount of potential energy. When released, this energy transforms into kinetic energy, powering turbines to generate electricity. It's the stored power of position turned into action. Then there's elastic potential energy, the energy contained in stretched or compressed objects. When you stretch it or squash it, you're storing energy in its configuration. Release the spring, and that energy propels it back to its original shape. Rubber bands, slingshots, and even trampolines all work because of elastic potential energy. It's why kids launching toy rockets with stretched bungees feel like little engineers of energy transformation. Chemical potential energy is another fascinating application. It hides within molecular configurations, the bonds of atoms themselves. Fuels like gasoline and food store chemical potential energy, ready to be released as heat or motion when burned or metabolized. That morning coffee you drink? It fuels your body's movement by releasing chemical potential energy locked inside the sugars and fats. Potential energy explains more than the mechanisms of physics. It reflects the fundamental principle of readiness. Whether in gigantic dams or the smallest stretched rubber band, it teaches us that stored energy is powerful, poised to change states, take action, and unleash motion. And the next time you witness something shift from stillness to motion, stop for a moment and think. The energy was always there, waiting in a state of potential, just needing the right conditions to make its grand appearance.